All right, we're going to do a really quick little lesson here on dimensional analysis. And hopefully this kind of clears up what this process is, how it works, and how you don't really need formulas to answer the questions from the book, and you don't need to memorize anything as long as you understand a couple key things. So every dimensional analysis problem that we're going to do in class falls into one of two categories. First of all, dimensional analysis and unit conversion kind of mean the same thing, okay? They basically mean the same thing. So we're using the dimensions that you're in, so like volume, time, and you're converting that dimensions from hour to minutes. It's just unit conversion. Anyways, it falls into two categories. Every problem is either a single unit, so we're going to be converting either a single unit, that would be an example of that would be like converting hours to minutes, or the problem is going to be converting a rate. So if you're converting a rate is different, right? So a rate is like converting miles per hour to, say, meters per second. So with a rate, you have two units. You're converting two things, miles to meters, and you're converting, miles per hour into meters. You're converting hours to seconds. So miles to meters and hours to second. Two conversions for a rate, and when you have a single unit, it's just a single conversion. And it can be fairly confusing because oftentimes when you are doing a single unit conversion, there are rates involved in that conversion. Oh my gosh, my computer is dying. Hold on, let me escape out of full screen here, see if that helps so my computer doesn't crash or something. Okay, great. So that's what we got going on there. All right, super. So the other thing you need to know is why dimensional analysis works. This technique I'm going to use is it has to do with things canceling. Like if you're going to simplify, for example, let's think of a fraction like 8 over, or let's do 4/30ths. If you're going to simplify 4 over 30, the fraction 4 over 30, you can kind of factor the top, which is like 2 times 2, and factor the bottom, which is 30 is 5 times 6, and 6 is 2 times 3. So you could write it as 5 times 2 times 3, or 2 times 3 times 5 or something. And when you have something in the top and something in the bottom, they cancel out. And what you're really doing there is 2 divided by 2 is 1. And so since this is equal to 1, and 1 times anything is itself, you can get the simplified fraction as just 2/15ths, right? Now, that was maybe a roundabout way to do the problem, but we're getting there. Okay, so it's the same thing with units. Like if you have a problem that says units can cancel just like these numbers will. So if you're like, all right, I am going to drive 100 miles. I drove 100 miles this week, right? And I know that every time I drive to and from work, I drive 25 miles, right? This is just a really basic example. When you answer the question, how many trips have you done? The answer is, well, 100 divided by 25. It's 100 miles I drove this week, and I did, it's 25 miles every time I drive to and from work. So that means 100 divided by 25 is not 4 miles. It's the number of trips that I made. The units cancel. They go away, okay? And we kind of do this all the time, but we don't really think about it. And so we're going to use that trick and what we know about multiplying fractions to answer these questions. So the first two I'm going to do, and then I'm going to have you guys can practice the second two, but feel free to pause the video to try them, or unpause just for a little bit and get a couple little hints so you can get started, see if you can do it by yourself. And I made these up very quickly. I hope they don't have any errors in them. So the first thing is we're going to convert 38 pounds 4 ounces into grams. 38 pounds 4 ounces into grams. And there's more than one way to do this. But the obvious choice to me is to write this 38 pounds 4 ounces as a single unit. So we have to either choose pounds or ounces, and I'm just going to write it as pounds. So the first thing you do is get the first thing into a single unit. So 38 pounds 4 ounces is equal to 38. Now, since there are 16 ounces in a pound, we're going to write this as plus 4 over 16, because if you had 38 pounds 16 ounces, that would be 39 pounds, because this would be a whole pound here. But it's not, it's 4 out of 16, so we're going to write that as a decimal, which should be 0.25. So we will end up with 38.25 or 38 plus 0.025, if you want to show that extra step, which is 38.25. So if someone weighs 38 pounds 4 ounces, they weigh 38.25 pounds. So have this as a single unit. So it's pretty obvious that with this equation that we're going from pounds to grams. We're doing a single unit conversion and not a rate conversion. So how we use dimensional analysis to do this, as I always taught the students, figure out your roadmap. How am I going to get from pounds to grams? So we can draw a little roadmap here, and we can say, so step one's our roadmap. We want to go from pounds. So what I would do, I think an easy way to do this is to go from pounds to kilograms, because I know that there are 2.2 pounds in a kilogram, okay? And we go from kilograms to grams. My pen is freaking out here, hold on. I think I got it fixed. Okay, from kilograms to grams. So we want to convert from pounds to kilograms, from kilograms to grams, and each of these arrows represents a multiplication that we're going to do. So we always start by taking our first unit, 38.25 pounds, and since this is a single unit, we're going to write that as a fraction with a fraction over 1, like this, okay? And we're going to do, there are more complicated problems in the video too, but so don't fret. Now, each of these arrows represents a conversion factor or a multiplication that I'm going to do. So I have 2 arrows in my conversion, so I can add 2 blanks before I get my answer. In this conversion, or in this fraction, we're going to write the conversion factor between pounds and kilograms. And I know that there are 2.2 pounds in 1 kilogram. So I can take this information, and I can take the fact that I know that units cancel if they're in the top and bottom of a fraction, and I know that since pounds is in top, 2.2 pounds, 2.2 pounds is going to go in bottom, and 1 kilogram is going to go in top. And then these units will cancel, right like this. And if I were to just divide, I would get my answer in kilograms, but I want it in grams. And I know that in 1 kilogram, there are 1,000 grams. So you need to know these conversions. So you can take things that are equal, you can multiply, and what that's going to do when you're done, kilograms cancels with kilograms, and you end up with this times 1,000, which is, what is that? Move that over 3 places, 38,250 divided by 2.2. So in the top I did 38.25 times 1 times 1,000. In the bottom I did 1 times 2.2 times 1 to get my answer, and then I would bust out a calculator. Hope this calculator has batteries. It does not. Hold on. Okay, I think I fixed it. 38,250 divided by 2.2. And we get, if someone's 38 pounds 4 ounces, they weigh 17,386 grams, roughly. Okay. So I used the units to figure out what to do with the numbers. So you just line them up, multiply across the top, multiply across the bottom, and then divide when you're done to get your answer. And I know that my answer is in grams because it's the only unit that is left that did not cancel. Okay, let's do a harder question. This one says a doctor orders 0.6 milligrams per kilogram of ibuprofen for a patient that weighs 172 pounds. The medication on hand has 100 milligrams of the pure medication suspended in 5 milliliters. How many milliliters of medication do we need to give to this patient? So in this question, is this a rate or is this a single unit conversion? Well, the way that we can tell is we can look at what it's asking us. It says, how many milliliters of medication do we need? Milliliters of medication is a single unit. So that means what I start with at the very beginning had better be a single unit and not a rate. So I can put a 1 down in the bottom. So what is everything based off of? The amount of medication that I'm going to give in milliliters is all based off of the weight of the patient. The bigger the patient is, the more medication that they're going to need, okay? So, and I think in most cases. So we can put 172 pounds here for the patient weight, okay? And we need to figure out our roadmap. I want to get from pounds, I need my answer in milliliters? Wait, what the heck, right? So we're gonna start with pounds. Our roadmap, what's our conversion? We're gonna start with the pounds of the patient. Okay, now this is a little bit tough, but we need to go from how much the patient weighs to how much medication to give. And the doctor says that I need to give 0.6 milligrams of medication, so of the pure drug, per kilogram that the patient weighs. Well, that's a problem because this person is weighed in pounds. So the first thing we need to do is get the patient weight into kilograms. Then we will have the connection between kilograms and milligrams. Okay, so the patient's weight in pounds and then the patient's weight in kilograms. Then we're going to take the patient's weight in kilograms and we're going to use that to tell us how much of the pure drug to give that patient. So that is going to convert to milligrams of the drug. In this case, it's ibuprofen. Okay, once we have that conversion, we are going to go from, what's the next connection? Do I have a connection between milligrams of drug and milliliters? Yes, I do. I know that there are 100 milligrams of pure drug in every 5 milliliters. So I do have that connection of the suspension, because the medication is suspended in a liquid, right? So there's 100 milligrams of drug in 5 milliliters present. I made these questions up quickly, so hopefully the numbers work out normally. And then we're going to go into the milliliters of the medication. So the medication and the pure drug are not necessarily the same thing. This would be pure ibuprofen. It's not pure ibuprofen that we're giving them. It's been diluted with something. So here's our conversion. This is our roadmap. This is what we're going to use to do our conversions here. Okay, so the first one is from pounds to kilograms. There are 3 arrows, so I'm going to have 3 multiplications that I'm going to do. Sorry, I wish my computer was faster. It is ridiculous. Okay, so the first one, I'm going from pounds to kilograms. There are 2.2 pounds and 1 kilogram. Okay, 2.2 pounds and 1 kilogram. There are 0.6 milligrams of pure drug per kilogram of body weight. That is the order from the doctor. So I am going to give, so just let's cancel our units. So pounds cancels with pounds. Oh man, such a lag, brutal. Okay, pounds cancel with pounds. So for every single kilogram, this is 0.6 milligrams per single kilogram. So for every single kilogram has to go on the bottom because kilogram is in top here. Every single kilogram of body weight, we are going to give 0.6 milligrams of drug. Okay, and now kilograms will cancel. Since kilograms is canceled, then I know that I need to figure out, I now know how many milligrams of the pure drug I would give, but I don't have it as pure, I have it as diluted, so I have to convert my 100 milligrams to 5 milliliters. Oh my gosh, computer cannot handle this. Okay, and then multiply across the top and multiply across the bottom to get our answer. So we bust out our calculator, or a different calculator that has batteries, which is 172 times 0.6 times 5, which is 516. Okay, and in the bottom, it's 100 times 2.2, which is 220. So how many milliliters of the pure drug am I going to give? Well, we do 516 divided by 220, which is 2.3, roughly, rounded to 2.3 milliliters. Okay, so if you divide those, our answer is I know my answer is in milliliters because kilograms cancel with kilograms, milligrams cancel with milligrams, and the only thing that's left is milliliters. That's the only unit that did not cancel. Okay, I've got 2 more problems here. These ones are maybe a little bit harder. I don't know. I'm just going to work through them. You can feel free to check, and then I'll upload this video. So, you infuse 2 liters in 7 hours. How fast is this in drops per minute if the machine uses a drop factor of 15 drops in 1 milliliter? Okay, so when you're infusing, and if you're a nurse and you're counting how many drops are happening, that's how you determine how much medication is kind of going to the patient if you know how much is in the bag. So we're going to set this up. This problem is not a single unit. This is a rate. And so we want our answer. We need our answer to be in drops per minute. Okay. We know that we are infusing. What's given to us is that we are infusing. So the top unit is kind of it's a volume. It's the liquid. The bottom unit is time. We know that we're infusing 2 liters in 7 hours. So we're going from liters per hour into drops per minute. That means I need to turn liters into drops, and I need to turn hours into minutes. So we have 2 conversions that we're going to have to do. We have 2 roadmaps that are going to have to happen. So liters, I'm going to go from from liters to milliliters, and the reason I knew to do that is because I know that 1 milliliter is 15 drops on the machine that we are observing. So that is we have the connection from milliliters to drops. We have the connection from liters to milliliters because I know that there are 1,000 milliliters in 1 liter. Okay, and then the last conversion is in a different unit, so I'm not going to connect it to this. We're converting hours to minutes. So there are 3 arrows in our dimensional analysis here, and so this is going to be, we're starting with 2 liters in 7 hours, okay, and I need that to end up in drops per minute. So the first thing I'm going to do is convert liters to drops. It does not matter which one you do first. I know that in 1 liter there are 1,000 milliliters, okay, and I know that, so we just canceled liters are done. They're out of here. Okay, now I need to know how many drops I'm going to have per milliliter. So if I were to multiply right now, this 2 liters would be 2,000 milliliters in 7 hours, but I want to know how many drops that's going to be. Okay, so this is, I need to convert milliliters into drops, and I know that the machine or the drip is doing in 1 milliliter, we will observe 15 drops, and that's what we can count. Okay, so convert milliliters, and I'm not done yet. The answers that are left over that have not canceled. So milliliters cancels liter. I have it in drops per hour, and that's going to be a huge number. We want to be able to come in and time it for a minute. So my last multiplication is going to be the time conversion. Now here's where it gets a little interesting. Hours is in the bottom. I know that there are 60 minutes in an hour. To get that unit to cancel, I'm going to put hours in top, because you need hours in the top to cancel with hours in the bottom. In 1 hour there are 60 minutes. And now the only units that remain are drops per minute, so I know that I will get the answer in the units that are desired. So this will be 2 times 1,000 times 15, which is 2,000 times 15, which is probably 30,000. Okay. Yeah, I think that makes sense. 30,000 over 7 times 60, which is 420. So if I want to know how many drops per minute we are observing, I do 30, 1, 2, 3, divided by 420. It is 71-ish, 71 drops per minute. So if I were to go in there and count for a minute, I should count 71 drops in a minute on that machine. Okay, last one. You infuse 13 milliliters per minute for 6 hours. What is the total volume infused? You guys try this one, give it a shot, and then I'm about to go over it. So, all right, here we go. All right, so is this a rate or is it a single unit? This is a single unit. It is, I can tell it's a single unit because the question asks, what is the total volume infused? Well, that is a single unit. That's just like liters or milliliters. It's not milliliters per hour. So I know that I'm starting with a single unit. So what determines the total volume that's infused? If we're infusing at 13 milliliters per minute, the thing that determines how much I give them is how long we set them on the drip for, right? Or how long we are administering it. So the given unit, what I start with is 6 hours. That's what determines, if it's a fixed rate, that's what determines how much volume I'm going to give them. So I'm infusing for 6 hours. So it's a single unit, so we just put a 1 in the bottom. We're not going to have another unit in the bottom like we did with the previous example. Okay? And then what we're going to do here is I'm converting. I don't have my roadmap yet. I have to do my roadmap. So we're going from hours. I want my answer to be in, I didn't specify here, so you could say, let's just say milliliters. Milliliters, if we wanted to put into liters, we could maybe do that too. I need to turn hours into milliliters. That's a weird connection. That's weird. But I do know the connection. I know that I'm doing 13 milliliters per minute. So if I can get my units into minutes, then I will be able to do the conversion that I need. So I'm going to first convert hours into minutes. So I know that I know how many minutes are an hour, so that's easy. Then I can convert minutes directly into milliliters. So I have an extra arrow here, but so I'm going from hours to minutes, and I can do minutes to milliliters because I know how fast it's dropping. So here's how we do it. In 1 hour, there are 60 minutes. I knew to put hours on the bottom because hours is in top here. The hours cancel. If I were to multiply right now, we would get the number of minutes that 6 hours is. So that's not helpful. I want my answer in milliliters. Multiplying again. I know that if this gives me the number of minutes that I'm going to be infusing, and I'm infusing 13 milliliters per minute, so I put 1 milliliter, or sorry, that's not wrong. That's not right. 1 minute in the bottom. So it's per single minute. Minute is in top. I want minute in the bottom. And every minute that passes, I'm infusing 13 milliliters. So if I want to find out the total volume infused, I do 6. Oh, sorry, minutes cancels with minutes. I do 6 times 60 times 13, to get that I am infusing 4,680 milliliters over the course of 6 hours. Now, if I asked for it in liters, if I had asked for this in liters, all that would, please don't crash, computer. Okay, there. So if we were to go to liters, all that does is add another arrow. I can add another multiplication here, and we end up, there are 1,000 milliliters in 1 liter, and all that's gonna do to my answer is move that decimal place over. So it would be 6 times 60 times 13, which is 4,680, divided by 1,000, which is 4.68 liters. There we go. Liters is what's left. Okay, that's it. Hope that was helpful. I'll get this uploaded for you, and yeah, all right. We'll see you soon. Okay, bye.